Welcome to this demonstration of the Waypoint path generator. In previous demos, I've shown how the program can be used to create paths of various types, such as circular, helical, and also various what I call grid search paths to allow you to cover an area to fly your drone over. In this video, I'd like to cover an additional type of path, a path that I call a mathematical path. If you go to any mathematical encyclopedia and go to the section on curves, you'll find a wide variety of curves that can be created mathematically. I've gone through and selected a number of curve shapes that I thought were interesting curve shapes that you might want to fly a drone along. And these include an elliptical path, a parabolic path, a cubic path, something called a trisectrix, a platonic path, of which there are a number of forms, something called a strophoid, a folium, which is basically an egg-shaped path, and finally a path referred to as a resonance curve, which looks like that. At this point, I will go through and demonstrate how you would generate one of these mathematical paths. All right. To generate one of these mathematical paths, I can either do it from the right mouse button pop-up menu, or I can do it from the pull-down menus at the top of the screen. The difference is all of the mathematical paths contain an origin. If you create a path from the insert path from the pull-down menus at the top of the screen, the path origin is the center of the map. On the other hand, if you right-click and say Add Path from the pop-up menu on the map, then the path is origin is where you basically clicked. So once you open up the dialog box, we have a dialog box that controls the generation of all the different kinds of mathematical paths. Using the pull down, I can, let's first look at the elliptical path. Elliptical path initially shows up as a circle. I can increase the size of it. Notice I can also scale this into an ellipse. Now the scale is a scale up in X. The Y scale is actually a scale down. Okay. I can also change the rotational angle of this path, and I can also notice there's a gap. I can change what I call the start angle to move that gap to a different location. All of these paths, by default, the drone is going to point towards the next waypoint in the path. If I turn on point of interest mode, then the drone will point to the origin of it. And alternatively, I could pick an entirely different waypoint or point of interest for the drone to point to during its path. Let's just switch this off so it just points to the direction. So we have basically an elliptical path that you can create. The parabolic path, let me undo the angle. The parabolic path is basically a path in the shape of a parabola. If I scale it down, let's change the size. Basically, the size is the distance between the two endpoints of the drone. And again, I can scale up this parabola. I can scale it down into Y, and likewise I can also rotate it. Okay. We have a cubic path. A cubic is in the form of a cubic. Let's just scale it down a little bit, and that's basically what the cubic path looks like. A very interesting path is what's called the trisectrix. Let's size it up. Notice that this path also has a gap in it, so I could change the start angle to maybe swing the gap over to here, increase the number of points to get a better looking curve. We also have something called a platonic. Now there's several forms of the botonic. This is a botonic of order 3. Using the order slide, I can, let's just size this up a little bit. I can change it from a triangular type of shape to a rectangular shape. And then this is a pentagon, kind of a hexagon. Not sure what a 7-sided shape is. And then we sort of have an octagon. Okay. Likewise, I can change the start angle as to where the drone is going to start. And this one probably makes more reasonable sense to do it as an order 3 or maybe order 4. We also have a strophoid path, which comes in, loops around, and then comes out again. And again, I can rotate this and change the size of it. Okay. And we also have what's called a folium, which is more or less an egg-shaped path that then you can rotate. And likewise, this does have a start angle also, where you can adjust where that gap is going to be placed. Lastly, we have a curve called a resonance curve. I'm going to scale this down quite a bit, both in the X and the Y. So our resonance curve, let's change the angle. And maybe I'll zoom it up and say, make it like that. And those are basically the different path types, mathematical path types that we have. At this point, I'd like to demonstrate some of the editing capabilities we have to allow you to make changes to paths that you've generated. First off, if I turn my paths on here, virtually all of the paths, with the exception of the manual path, virtually all the paths you can redefine and bring up the dialog box that we used to create them and adjust them, however way you want to adjust them. Okay. However, once you join your paths together, you can no longer do that redefine. So I'm going to start by taking these 4 paths, and I'm going to join these together. I will zoom in here very quickly, and I'll just join this waypoint to this waypoint, right-click, and tell it to join the paths, but delete the originals. Okay. I'll join this waypoint to this one. Again, right-click, join paths, delete the original paths. Okay. And now I'll just zoom out a little bit here, and let's see. I'll take this waypoint, and this waypoint, and again, right-click, join paths, delete the originals. All right, at this point, maybe I'll take the path that has a really long name. I'll go and right-click here and edit the properties of the path, and I can change the name. School, helix in and out, and it changes the name of that path. Now at this point with the path selected, I could, if I want to check and see what it looks like, I can output it as a KML file, and then I can bring in, open up Google Earth, do an open, and find the waypoints KML. And it reads it in, and in a second I'll be zoomed in and I can see what the path looks like. So notice I do get the path shape, but it looks like I've got some weird stuff as far my altitudes are not quite correct. Notice that the drone comes in, drops down, but when it comes out, it jumps up to a high altitude instead of starting, say, low and then rising, it comes up. So I must have messed up on the helix. Actually, I did it on purpose to show you how you can fix it. So let's just minimize this. Now, one way you can fix items is I can pick a waypoint here, and if I right-click, I can go edit the properties of that waypoint. And using the waypoint properties dialog, I could come in and step through my waypoints. I could start adjusting the altitudes. to get the altitudes I want. Okay. However, there's actually a better way of doing that, and that's what I want to show you. So I will pick this entire path, and I'm going to, at this point, right-click and edit the path altitude. And what it does is it basically gives me a graph of the path, and it graphs the altitude. And initially, I'm going to reset the altitude of the entire path to about 60. Okay. Now when I come out of it, notice when I move my cursor over the waypoints, the altitude of each of the waypoints is 60, no matter where I go, the entire path. Now I'm going to zoom in here, and let's just say that from waypoint 32 to 43, I want to be at an altitude of 10. So what I'm going to do is pick the entire path again, right-click, go back into the edit the path altitude, and now unclick all waypoints, move this up to 32, and move this one down to 43. I'll change the, I want to set the altitude, change the altitude to 10, and apply that. So at this point, if I close out of it, notice that I'm starting at an altitude of 60. Here I'm 60, here I'm 60, 60, 60, and then we're still 60, and then we drop down to 10. So we have the height of that right. However, this rapid drop from 60 to 10 is a little bit too extreme for me. So I'm going to go back in and edit the altitude again. In this case, I want to basically drop down over a wider range of waypoints. So I'll move up to this slider up to waypoint 32, and I want to start dropping maybe at waypoint 20. And at waypoint 20, I want to go from an altitude of 60 down to an altitude of 10. Apply that. Oh, have to set the altitude. Apply it. And now notice I have a nice smooth curve as it drops in altitude. Likewise, on the other side here, I want to go maybe from 43 to, let's say, 43 to 53. So I'll move this up to 53. Move this up to 43. Reverse these around. So at this end, I want to start an altitude of 10 and go up to an altitude again of 60. Apply that. And now that I've got my altitudes correctly, I'm going to actually tell it to adjust the heading or turn on POI mode. Apply that. And now I've adjusted the heading and also the gimbal direction so that it's going to point towards the center. And actually what I'll do is I'll tell it to point to the school, and the center of the school is right here. I'll close out of this. Let's go and pick this and re-output it to the KML file. And now just come in here and open it back up. Yes. And now after opening it back up, it looks a little nicer. So it stays at an altitude of 60, drops down to an altitude of 10 meters, and then rises back up to an altitude of 60 to where it finishes. Once I've verified that the altitude and the path looks correct, the next step would be to output it into a form where I can read it into the Litchi Mission Hub application. So with the path selected, I'll output the selected path and tell it to output it from Mission Hub. If I then import, open up Mission Hub, I'll go into my mission, say import, import a new mission, and notice it zooms up around. and locates me. And if I pick one of these waypoints, notice that I'm in altitude of 60. Also notice that the gimbal pitch is set to interpolate, and currently with an angle of negative 12 degrees. And as I progress along the path, I should at some point see the altitude change, the heading change, and the gimbal pitch change. So I'll just start stepping around. The gimbal pitch is still negative 12, which is what I'd kind of expect initially. But at some point, once I get in maybe to here, I should start seeing the gimbal pitch change, which it is. Also, at this point, the altitude's dropping till I'm at altitude of 10. I'll just move around, and then now we're starting to rise up again as we come out of the circular helix, back up to an altitude of 60, which we stay at to the end of the mission. So at this point, I could save it, and then I could go out to the field and fly the mission. Now, someone who is a serious drone enthusiast might actually own multiple drones of different types. The Litchi Mission Hub application is used to generate flight paths for the DJI series of drones, but there is another application called Mission Planner, which is used to do the same thing, but for drones with a different flight controller. A new addition to the program is the ability to output your path into a format for Mission Planner, although I will admit that the Mission Planner output is not fully as implemented as the Litchi app. Regardless, with the path still selected, I will right-click and output it. In this case, I'm going to output it from Mission Planner. I'll open up Mission Planner and load in the Waypoint file that I just generated. And notice I get the same shape of path that I got before. So this ability would allow someone who owns both types of drones to be able to plan a mission within the Waypoint path generator, but then output it to either one, maybe two types of drones to fly. Hopefully through time, the Waypoint path generator will be able to support additional types of drones. That concludes this demonstration, and I certainly hope that you enjoyed it. Thank you very much. Goodbye.